So we now know that we're going to have a bunch of candidates for the absolute maximum and absolute minimum value. And those candidates occur at they are rather either endpoints of the interval or critical numbers. So when we're trying to find the absolute maximum value or absolute minimum value of a function, and by the way, you may not be asked for the word absolute. You might just be asked, what's the maximum value? What's the minimum value? But if you're asked to find that, and we're given a function on a closed interval, well, we're going to perform this thing called the candidates test. Okay? And some teachers call it the candidates test, some teachers call it something else, but give grading in popularity there. The candidates test, the idea is that we collect all of our candidates and we plug them all, these are all x values where the absolute extreme could occur. We plug them all into the original function. And that's key. Remember, so far when we've done our tests, the first derivative test and the concavity test, we've been plugging values into the first or second derivative. Now we are plugging values into the original function. Okay? The highest value gets to be absolute max, the lowest value gets to be absolute min. All the other ones are neither the absolute max nor the absolute min. Thanks for playing. You don't win any prizes. Okay? And then after we draw our conclusions, just make sure you answer the question. Because again, sometimes they ask, where does the absolute maximum occur? And other times they ask, what is the absolute maximum? Sometimes they ask for both. So just make sure that you're answering whatever the question happens to be. Example number 18, we're given this function. We're asked what is the absolute maximum value of the function? So let's go ahead and do that. So first of all, we need to get our critical numbers, if there are any, because critical numbers are some of the candidates. So critical numbers occur when the derivative is equal to 0. We have our function, which means we need our derivative. So let's get f prime of x, and we can quickly derive this and see that f prime is equal to 4 minus 2x. Okay? Critical numbers occur when the first derivative does not exist or equals 0. This first derivative is a line, so it always exists. However, it equals 0 when x is equal to 2. So 2 is one of our candidates, assuming that it's inside of the interval. Well, the interval goes from 0 to 4, so it is inside the interval. Okay, if we had a critical number, say, that was equal to 12, 12 would not be in the interval that we're interested in. We would just toss that one out. Okay, but 2 is in the interval from 0 to 4, so that gives us a total of 3 candidates. Okay, 0, 2, and 4. We're going to take those 3 candidates and we're going to plug them into the original function. All right, so we are interested in f's value at 0, f's value at 2, and f's value at 4. We have to plug all 3 candidates into the original function. When we plug 0 into the original function, we have 4 times 0 minus 0 plus 6. So f of 0, that's the quick one to do. That's equal to 6. Now we're going to plug in our next candidate, which is 2. 4 times 2 is 8. 2 squared is 4, so we have 8 minus 4, which is 4, plus 6 more, so that's going to be 10. 8 minus 4 plus 6, which happens to be 10. Okay. And finally, we're going to plug in 4. When we plug 4 in, 4 times 4 is 16, minus 16 plus 6. Right? 16 minus 16 plus 6. That also gives us an answer of 6. What were we asked to do? We were asked to find the absolute maximum value. So we compare our 3 answers, 6, 10, and 6. Obviously, this is the highest. That's going to be the one that we focus on. Okay, so we've been able to draw our conclusion. The absolute maximum value is 10.